Okay, today we're going to be looking at properties of covalent bonding and ionic bonding and how that leads to some physical properties that we can see in these types of molecules. So first I want to do a little review of the two reading assignments that you did. So review of electronegativity. We actually talked about electronegativity way back in first trimester when we were looking at periodic trends. So electronegativity is the desire for atoms to take in electrons. If atoms really want to take in electrons, meaning they want to form negative ions or just take in electrons to fill their octet, they are going to have higher electronegativity values. Now this happens when an element is closer to fluorine on the periodic table. Those elements are more electronegative, so upwards and to the right on the periodic table, they are more electronegative. We can use electronegativity to determine the polarity of bonds. And one thing to note, noble gases don't have electronegativity values because they don't want to take in any extra electrons because they are already stable with their full octets. Quick review of intramolecular forces. These are the forces holding atoms together inside a molecule. So this is where we have covalent and we have ionic bonds. Those are the two types of intramolecular forces that we have talked about. We can have polar covalent and non-polar covalent bond, which just look at how those electrons are being shared. Now these hold the molecule together, but when we have substances in real life, we don't have just one molecule of something. So that's where our intermolecular forces come in. Now the intra, so the ones inside the molecule, covalent or ionic, are determined by the difference in electronegativity. Okay, so that's where the electronegativity comes in. And when we have a large electronegativity difference between our two atoms in our bond, that's when we get ionic. When we have a lesser difference, that's when we get covalent, and even lesser, down to 0, that's where we have nonpolar covalent, where they're sharing those electrons equally. Now remember that this is a continuum. Things are more ionic or more covalent or more polar covalent or more nonpolar covalent. It's not a set rule where at this benchmark something becomes ionic all of a sudden. So we can kind of see mixing of properties sometimes because of this. Now, intermolecular forces are forces between molecules. Okay, these depend on the polarity of the molecule, not on the polarity of the bond. So if we have a symmetrical molecule, okay, that has 4 bonds to it, and each of those are polar bonds. Because it is symmetrical like that, it's going to end up actually being a non-polar molecule, even though it has polar bonds. Okay, so a polar bond doesn't necessarily mean a polar molecule. Okay, we have 3 types of intermolecular forces. We have dispersion forces, dipole-dipole, and hydrogen. Now, these are listed in least to greatest as far as strength and least to greatest as far as polarity. So dispersion forces occur even when a molecule isn't polar at all. So every single molecule or compound is going to have some sort of dispersion force in it. But those are really weak intermolecular forces. The dipole-dipole then occur when we have that difference in polarity. Okay, so these happen in polar molecules, or even ones that are like borderline polar molecules. The hydrogen bonds then happen when we have hydrogen on one molecule, and on the other molecule we have a fluorine, nitrogen, or chlorine to bond to, or to attract to. Okay, now you don't need to know the names of these 3 different forces. So you don't need to be able to answer that these are dispersion, these are dipole-dipole, these are hydrogen. You don't have to be able to tell me or your teacher what those names are on your test. What you do need to understand is how these relate to properties and how they relate to polarity. Okay, so you would need to be able to tell me that molecules have weak intermolecular forces when they are less polar. Okay, or something like molecules this compound has this property because it has really strong intermolecular forces, and I know that because it is polar, and polar molecules have stronger intermolecular forces. So that leads us into our new information, which is what are those properties, okay? And which of these intermolecular forces actually apply to our two different types of bonding. So some properties of ionic bonding. Ionic bonding as an intramolecular force is really strong in and of itself. Okay, so that ionic bond that we learned about is really strong. But ionic compounds have a very high polarity. They have that positive and negative charge that leads to strong intermolecular forces. These strong forces contribute to the following properties, such as high melting point, high boiling point. They're hard and brittle. They conduct electricity, but they only conduct electricity when in liquid form or when dissolved in water. Okay, so if they are in a solid, they do not conduct electricity. They're good insulators, which means when they are in a solid, they're not going to conduct electricity. They are usually solids or liquids at room temperature. Okay. Now, one thing to note is we did not talk about what's called metallic bonding. And metallic bonding occurs just between metals. So when we think of like iron or copper, wire or steel even, that has to do with metallic bonding. So when you're thinking, if you're questioning like, well, they don't conduct electricity in solid form, how do we have like copper wire that we use for electricity? Well, copper wire is bonded with metallic bonding, not ionic bonding. Some properties of covalent bonding then. Covalent bonding in itself is also a very strong intramolecular force. Covalent compounds have lower and possibly no polarity though, which leads to weaker intermolecular forces. Okay, so even though the covalent bond itself is very strong, the intermolecular forces are weak, or weaker than ionic. These weaker forces contribute to the following properties: lower melting point, lower boiling point. They do not conduct electricity in any form or when dissolved in water, so they're not conducting electricity whether they're a solid, liquid, or gas. They are bad insulators, okay? And they're usually gases or liquids at room temperature. One other thing to note with these is because of this low melting and boiling point, they evaporate really quickly. So one good example is like rubbing alcohol. If you've ever spilled rubbing alcohol on yourself, it will evaporate pretty quickly and you're left with that cold feeling. Same with nail polish. The acetone in nail polish is a covalent compound, and it evaporates really quickly, leaving that cold feeling behind as it takes some of that energy with it from your skin. What you need to know out of these, you need to be able to identify what type of compound you think it would be based on a list of properties, and you need to be able to list some properties of each type of compounds. Okay, so a good thing to remember is that this is a continuum. So if you have something with like a medium boiling point and a medium melting point, that doesn't necessarily mean that you can't determine. You would just say it's somewhere right in the middle, and then you'd use some of the other things like, does it conduct electricity? Is it a good insulator? What state is it at room temperature? To maybe help you determine, does it fall more towards covalent or does it fall more towards ionic? Okay, if you have any questions on this, be sure you're asking your teacher because this is kind of complicated as far as the whole idea of it being a continuum and not a black and white kind of situation. Make sure you did your notes and then move on to those practice activities.